We'll talk about test-driven development in this presentation. When it comes to driving development of applications, how do we possibly drive that development using test cases? That often seems to be a little confusing to us because we can sit down and write code and produce code to do stuff, but how do you really start by writing test cases and then writing code and use those test cases to really channel, focus, and drive the development? Well, it's possible if we take a certain disciplined approach in creating this. Let's say we are developing an application and we have a set of user stories given to us. Oftentimes the user stories are of different size. Some are really big, some are really small. And those stories could belong to what's called a project backlog. When it comes to a release backlog, this is what we plan to implement possibly in the current release. Then we take the sprint backlog or iteration backlog, however you want to call it. In the sprint or iteration backlog, we really have what we plan to do in the current sprint. And these are the features that your customers have said as high priority, and the team says we're going to implement these things. Once we decide on the stories to implement, those stories in the sprint backlog must be relatively fine-grained. They shouldn't be really large. Stories should be implemented of the size to be implemented within a matter of hours to a day or so. Or in other words, the time it should take to implement a story should be a fraction of a sprint. So that is a relatively small size, and we need to break stories so that they are small in size relatively to that. Once we take a story, we're going to go from stories to these test cases. The test cases provide a way to validate and verify and to know that we are done. This is what we want to do, and look, these tests are passing, so we have completed these tasks. How do we go from user stories to these tests? Well, Ron Jeffries talks about the so-called 3 C's. He talks about 3 C's as these 3 C's. The first one is a card, and this is an index card, and you write the story on the index card. This essentially tells you what the story is about. For example, as a customer, I can deposit money into my account. Or as a customer, I can transfer money from my checking account into my savings account. So these could be the stories. The second one is conversation. This is what the team does. The testers, the business analysts, the programmers, they can sit together and talk about and understand what the nitty-gritty details are. At any time, they could ask questions, clarify, change based on our renewed understanding of what a particular story is. The third one is the confirmation. This is where the tests come in. So at the back of the index card, we jot down the test cases we want to write potentially. So the testers and the business analysts can sit down and start writing these based on the domain and the application that is being built. For example, for the story that says as a customer, I can deposit money into the account, the test could be customer deposits $100. Customer deposits $5,000 because the rules for depositing money varies. In some banks and some countries, if you deposit a large amount, there are certain sequence of things that have to happen. A certain monitoring that kicks in due to governmental regulations, for example. So customer deposits money into somebody else's account. Well, that makes a difference. If I walk up to the bank, if I deposit money into my own account, they give me a receipt for that. If I walk up and deposit money into somebody else's account, they don't give me a receipt for it. They say, thanks for depositing, and this amount was deposited. The receipt actually they give me include the amount deposited, but not the balance and the account information, other details. So it really matters who is depositing the money as well. That could go into a test. So these are confirmation test cases from the problem, the business domain point of view and the application point of view that the testers and the business analysts are jotting down on the back of the index card. So that gives us the focus to what to start with. Programmers, as they sit down to implement the code, have these integration points. New tests could get added at any time. Some tests could get removed. Some tests could get modified as our understanding evolves. So this is an evolving series of test cases. Programmers can integrate these tests into the code. These are usually functional tests and acceptance tests, fairly coarse-grained tests. And the programmers often write low-level tests, unit tests, before they come to integrate this code. But once the code gets integrated, these serve as executable documentation for repeatedly executing these tests as the code evolves and the application features are evolved as well. Well, Bill Wake talks about an acronym called INVEST. Let's talk about what INVEST really is. So he talks about INVEST over here, and he talks about INVEST to be that the stories should be independent of each other. So he says that stories should be independent of each other. Don't try to intricately relate stories together as much as possible. Define each story separately so development can be done in whatever order that may make sense. He says that not only should the stories be independent, independent, there we go. And not only the stories should be independent, they should be negotiable as well. So why negotiable? Well, the idea behind negotiability is, if I know how to type, negotiable is that you can discuss and determine what the real feature should be. Hey, should it really constrain these set of data? Should I worry about these kinds of customers? Should I worry about these kinds of amounts be deposited? Should I think about distribution? Should I think about access? Should I think about time? Should I think about time zone? Whatever the details are, you are conversing, but you're also negotiating to say, could we implement this aspect first, then come back to these other aspects? Is this really important feature, or should we compromise to get better performance or better feature, whatever that could be? Or the programmer could come and say, well, I just realized that we could do these things a little differently for these reasons. Are you willing to make those changes? And so this is where the programmers, the testers, and the business analysts have to sit together and decide what should really get implemented, a refinement of the story as it gets implemented. So that is about the I and N in INVEST. The next one is valuable. The story should have real value, business value to the application. If something is a back-end process that you're trying to do to get the application up and going, don't bring them as stories, instead keep them as other tasks to be completed, but stories should really focus on business value that is for either the customer or the organization that is, building the application. Stories has to be estimable. So the idea behind this is you don't want stories to be way too big that you say, oh, that will take about 7 weeks to implement. It's got to be something you can fairly estimate in matter of fractions of time that a sprint is going to take. And then finally, the stories have to be small. A very large story is called an epic. You want stories to be relatively small in size. But for our discussion, what we are really interested in this T, which is testable. So fundamentally, the way we write stories, the way we express stories is that we should be able to have them as testable. That becomes extremely critical. If you cannot test a story, then you have not really implemented the story in a way that it can be automated and tested. And so we need to start rethinking the way we define these stories from the testability point of view. That becomes extremely important. But when it comes to the levels of tests, we talked about this in the previous presentation. We talked about how different levels, for example, at the unit level, at the controller or service level, and UI level, we could have different types of tests and different granularity of tests. So unit test is at the very low level of code. You can have functional test, acceptance test, UI level test, and so on. And we talked about this test pyramid. So keep that in mind when you come to develop these test cases. Who drives these tests depends on the nature of these tests. Unit test is predominantly driven by programmers. Functional test and acceptance test are predominantly driven by business analysts and testers. So the programmers have to support the business analysts and testers for them to be able to integrate and run these higher level functional and automated tests. Similarly, testers have to support the programmers by writing automated tests so that when the programmers do evolve the code, fix errors or enhance and add features, there can be a quick feedback loop that the code that worked before continues to work now. That kind of feedback is extremely valuable. That's what the testers and the business analysts do to support the programmers, and the programmers have to support the testers to integrate and run those test cases as well. It's definitely a team effort overall. So typically you would start with user stories, assuming that application is significantly big enough, and you would start with user stories, and then for each of the story, make sure the size of the story is granular enough, and then write the story in an index card. in the back of the index card, jot down the tests that you would like to have. And these tests can be added, removed, evolved, changed, modified as we get better understanding. Once you have these stories written up, you can integrate these stories or make them pending on the system by writing them as executable documentation. You could write these stories using tools like RSpec or Cucumber or ECB or SpecFlow, whatever the tool you use, or Jasmine for JavaScript. So whatever tool that you use, these are functional testing or BDD or behavior-driven design tools where you can start writing acceptance tests and functional tests. So I mentioned quite a number of tools over here. RSpec, for example, is one. SpecFlow is for .NET and C#. There is also Cucumber, for example, you could use. There is also tools like FIT, which stands for Framework for Integration Testing, and Fitness as well. So these are tools that can help us to write these business requirements as series of test examples. And then once we have these test examples, we can execute them when the code gets integrated. The programmer then looks at these stories, looks at these test cases and says, that's where I'm heading towards, and then starts thinking about the problem, either takes a top-down or a bottom-up approach and starts writing unit tests on small units of code. And then as they come up to higher levels, they have these functional tests that are pending and they integrate them. The acceptance tests and functional tests get integrated with the code so all the tests can start passing. And of course, as we start continuing to evolve the code, add features and make changes, we know that these tests that are at the unit level, functional level, acceptance testing, integration testing, all of those continue to pass, giving us a quick feedback that the code that worked yesterday continues to work today as we make changes to the application. In my application that I have, a predominant application in production, every single time I make a change to the code, immediately all the automated tests are run, and I only push to production. In fact, I only check the code in when all the tests actually pass, all the automated tests. If any of the tests fail because of the change I made, I have to immediately fix that, either roll back the code and then rethink what I'm doing, or figure out why I broke the expectations and fix the code and have all the tests passing. And when all the tests are passing, I am ready to check in the code, and then that can move into production after that. So what are some of the benefits of driving the code, driving the development using these test cases? Well, there are two fundamental benefits to having automated test cases. One is regression. You want to make sure the code that worked before continues to work now. In software systems, software is nonlinear. You could modify something here and something over here ends up breaking. Why do things like that happen? Sometimes we violate data integrity by modifying some data. Sometimes we mess up memory when the program is executing. Sometimes we modify certain expectations on a certain data's behavior. And as a result, the code that worked before doesn't work anymore. And we may be making a very trivial change, a simple change, a benign change, but oftentimes these come back to bite us in the back. And when do we really find out these things went wrong? We often find out these things went wrong when somebody, poor user or tester, stumbles on these things. And for somebody to stumble on the problem, they have to exercise that piece of code in a certain order. The chances of this happening through manual verification is rather slim, because somebody testing this manually has to go through enormous number of permutation combination, and usually there's not enough time and money to do this. Or even if we do, we'd have to hire a very large team to exploit all these combinations, not very practical at all. But using these automated tests, we can set up scenarios to evaluate over and over. So every time a code changes, all these thousands of scenarios, variations of way to access the application can be executed, automated on the code, and we get a very quick feedback within minutes, often less, that everything that worked before is working now. On one application I maintain, every time I modify the code, I got a little background window where the minute it sees a code change, it automatically runs all the tests. If any of the tests fail, I know that something is wrong and I take care of it right away. So compiling the code becomes really a trivial operation which we can skip, because we want to go from editing the code to hitting the save button to a test running right away. That is all we really care about. So we can get to this kind of really fast feedback loops very quickly by using nice tools, but more so nice techniques to write code. But that kind of regression can help us to know that the code that worked before continues to work, and that gives enormous amount of confidence for us that we have not broken anything that worked before. That can help us to move from getting us change in requirement and moving that to production rather very quickly. Like I mentioned earlier, when I received a change request, within 15 minutes, I was able to implement that feature and deploy it, knowing that everything that worked before continues to work, and the new test I wrote for this new feature is also working. There are times when I make a critical change and several tests end up failing, and said, oh dear, I'm glad these tests failed because I can fix them right away. Had not had these test cases, I would have done some manual testing here and there, but the real failure emerges when users start using the application, and that's not really fun at all. So it's important for us to have these kind of automated tests to give us the regression benefit, and I find that the regression benefit is something that's pretty long lasting. The other benefit is the design benefit. What I mean by design benefit is that you are able to influence your code's design through these test cases. And the reason for that is when you're writing these test cases, often before even writing the code, it puts us in the shoe of the person using the code. So we think about, is this a good way to send these data? Are these the parameters I want to send? Is this the way I want to model this particular object? So we think through a lot, and so we are really doing very tactical design at the time of writing these test cases. And in fact, there are a couple of things we need to keep in mind. If somebody comes to you and says, this code is not testable, these are called euphemisms. What they really are telling you is this code and its design sucks. That's what it really means. So if a code is not testable, it simply means that it's been poorly designed. So design influences of test-driven development and automated testing is enormous. But of course, there's one challenge here. When you're writing these test cases, you have to really stay conscious when writing these test cases. If you simply plow through and make this a mechanical operation of coding the test and writing the code, you're not getting the design benefit. So while the regression benefit is pretty long lasting, the design benefit only comes when we apply it, when we really pay attention to it, when we are conscious and we steer the design based on the whispers that we hear from the test cases. That's right. Test cases whisper to us all the time. They are telling us, hey, this code sucks. Don't do this. I don't like the way you're developing this code. It's too much coupling here. This is too non-cohesive. This method is too long. It's hard to test. The tests are crying for help. And if you listen to the test when you're writing code, you're able to steer your design based on those whispers. If on the other hand, if we don't listen to the test and simply write some test arbitrarily and then throw out some code to make it work, we're not getting the design benefits out of it. Now, one of the things I've realized over time is that the more we do test-driven development, it changes the way we think. It changes the way we design. It changes the way we approach a problem. So in that regard, we could talk about the duration and the benefits that test-driven development provides. And I'm going to say there is probably a point of diminishing return when it comes to design, but the regression benefit is quite long-lasting. So let's discuss that a little bit further. So here's a way I think about this. When it comes to timeline, as time goes on and the benefit we get, I feel that the benefit of regression is pretty long lasting. We start writing automated tests, and then in proportion to that, we start getting the benefits of regression. Every time we write a test, there is another little test that's sitting there watching over our shoulders. As we modify the code, it tells us whether the code is working or not. We get that kind of feedback. So the regression benefit is pretty long lasting. On the other hand, if I'm not doing any test-driven development, I'm not getting the design benefit of modularity, better decoupling of the code, shorter methods, a lot of other design benefits we get. It's really not as that easy to sense that in the beginning. But once we start doing test-driven development, we fall into a certain way of developing code that once we reap that benefit, the more we do TDD, the less we actually continue to get that design benefit. And what I mean by that is, I don't see the TDD as being useful as a training wheel for this better design after a certain time. Now, clearly, if somebody comes and modifies the code, we get the feedback, but that's a regression feedback. It might also help newer team members to follow into a structure if there are enough test cases. But nevertheless, I feel that after doing TDD for a few years, that design benefit kind of washes away because our mind has changed quite a bit with respect to how we design. So the question then is, should we still do test-driven development? And the answer is yes, absolutely. I do test-driven development even today, even though my design benefits I get out of it is a lot less today than I used to a few years ago. The regression benefit is extremely valuable and it keeps me going. And so that's one of the reasons why I still like to do test-driven development and write automated tests. So given this, there are some really nice benefits we saw for having these automated tests. And so these two benefits are probably the most significant, to get the regression benefit and the design benefit. In the next few presentations, we'll dig into each one of them. We'll talk about the regression benefit, and then at more length, we'll talk about the design benefit and how we will do this. And for each of these, we will try it with some specific code examples.